we're going to see one last topic called MRO. MRO, which is nothing but a method resolution order, which is almost similar to that of what we see with the polymorphism. Okay, what is polymorphism? When I want to call a specific function, then I need to call the object of that particular class constructor so that I can print that particular function. Okay, similarly, let me create a class A that has a function. Let me put a self, and then it is going to print A. Okay, now I'm going to have a class B, which is actually inherited class A, that has a function with a self as a reference, and it is printing a B. Okay, again I have a class C that is also inheriting a class A, but that has a function, same reference, but with a different output together. Now I'm going to have a final class D, which inherits B as well as C. Now this is called as multiple inheritance. The inheritance syntax that you see at line number 55 is what we call it as multiple, because within one class I'm trying to inherit two classes. So now def function self print of D. Okay. Now what I'm going to do, I'm going to create an object for my D constructor, the last child class, and using that object, when I call the function, the polymorphism concept will come into picture. So obviously I'm going to get output as a D. Now this case, absolutely fine. This is a running, or this is a running as expected. Now I'm going to take away this function. Let me put pass over here. Pass means go back to the next execute statement. Now the polymorphism will have again a dilemma, because when it reaches D, D doesn't have any function. So now the polymorphism is eradicated. So what happened? Either it can go to C, either it can go to B, or it can go to A. So beauty is that now it can go to all three classes. Now during this kind of a scenario, what kind of preference that the class will give? That's what we're gonna see. Now when I run, look at that. Output B is printing. If you're wondering why that is printing, because in my class D, I'm inheriting B as the first class. So whatever that is very near to my parent class, that will get prioritized and that function will get printed. This is what we call it as method resolution order. If you have a doubt, let me put like C comma B. Now which class is near to my D class? Class C. So now when I run, it will print the letter C. So this is what we do call it as MRO, method resolution order. Fine. So this method resolution order work in such a way that whenever a polymorphism doesn't get categorized or it cannot apply polymorphism, it will just try to catch the nearby search, nearby class. This something works only with the latest version of Python. If it is an older version of Python, say 2.7, 2.6 and other versions, right, it will go to the deep search. It will go to C and B, and C and B is already inheriting A, so it will print A. So that is what we call it as deep search. That happened during the older version of Python, during the 2.7 version of Python. But in 3. Version of Python, it gives the preference to the nearby search. This is what we do call it as MRO, method resolution order. Okay. Even though we don't use this predominantly in a real-time situation, but this will come in handy when you go for interviews. Take my words, if you go for a second round interview, especially when they want to tackle you by giving some toughest question, then MRO will be one of the questions. So make sure that you understand the logic. To understand this MRO logic, you need to understand the polymorphism logic. Okay. So this is what MRO is all about, guys. So we'll see in some other video with some other content. Okay. Thank you.